All right, video 3 dealing with inverse trig functions. The first video was just, here's the definition of inverse sine, inverse cosine, inverse tangent with a few examples. Video 2, deep into composing functions. Now, the goal is how can I find the inverse of any trig function, namely for this video, inverse secant, inverse cosecant, inverse cotangent. And the beauty is you can't think of secant outside of cosine. We already know that. You can't think of cosecant outside of sine. And then cotangent, we never really defined cotangent in terms of tangent. But we do know that tangent is the output was y over x. Cotangent is going to be x over y. And there is something that's important about the graph of cotangent that'll help us define the inverse. So we're going to run through an example of each. I'm going to talk about the theory, the concept, while we do an example where I show you here's how you find the answer. So we're going to do both at the same time. So let's dive right in. Bow! Okay, so we have the notation, the inverse of cosecant, also called arc cosecant. Right? The inverse means you've swapped the x and the y value, which is what this says. So before I go into all of this formal notation and definition and domain and range, let's dive into an example and see, okay, how would I work an example based on what I already know about cosecant? And then we'll see, okay, oh, that makes sense, or that makes sense. Oh, y can't be 0. That makes sense as well. So let's dive right in. Cosecant. So cosecant inverse of 2, we're trying to find the angle. All right, so we're thinking backwards. Cosecant of theta equals 2. Now, I already know that if I'm going to find the inverse of cosecant, it's going to mean taking the cosecant values and swapping the input and output. Okay, so this is straight definition of any inverse function. So nothing new here, but we defined cosecant in terms of sine. Cosecant of an angle equals 2 if and only if sine of theta equals 1/2. Okay, so we are still thinking of cosecant the same way, but here's where it gets tricky. If I want to find sine inverse of any value, the angle is going to live between negative pi over 2 and pi over 2. Okay, so we're still going to find an angle for cosecant inverse also that lives between negative pi over 2 and pi over 2, right? Because these are the numbers we need to find. So now the question is this. So here's the process. All right, we know the range of cosecant inverse is the same range as sine inverse. So the range of cosecant inverse is between negative pi over 2 and pi over 2, just like sine. We know that sine of 0 is 0, which means cosecant of 0 is undefined. So something crazy happens at 0. Skirt, I got to take that point out. Doesn't exist. Okay, so that's the theory. The theory is the angles for cosecant and sine are the same. Therefore, the outputs of secant and cosecant are the same range. But here's the process. So if I want to actually find cosecant of inverse of 2, then I have to find sine inverse of 1/2. Okay, so every cosecant problem, just like before, becomes a sine problem. Cosecant inverse of a number becomes sine inverse of its reciprocal. Same angle gives me out reciprocal values. Okay, now the problem becomes sine of 1/2, which means my y value is 1/2. What angle gives me a y value of 1/2? I know that that's pi over 6. Theta is pi over 6. So that's it. Now, there's a lot of theory going on here. Okay, so let me talk about the domain for a second I think it's important, but that's not going to determine. I mean, you'll still be able to evaluate cosecant inverse even if you don't fully understand this notation for the domain. I know the domain of sine inverse. The domain of sine inverse is always between -1 and 1. Okay? We know that on the unit circle, as you move around, the y values on the unit circle bounce between 1 and -1, 1 and -1. They're always there. Okay? Well, if I take the reciprocal, so this is where we live for the domain of sine inverse. What's the reciprocal of 1? It's 1. What's the reciprocal of -1? It's 1. But as I get closer to 0, what's the reciprocal of 1/2? It's 2. What's the reciprocal of 1/3? It's 3. What's the reciprocal of 1/4? It's 4. So here's what that means. If I take any number, all the numbers between -1 and 1, and I find the reciprocal of them, all the positive values between 0 and 1 blast off to infinity. And all the numbers between 0 and -1 blast off to negative infinity. So all this means is, if the domain of sine inverse is all numbers between 0 and 1, which we would write like this, x is between -1 and 1. If that's the domain of sine inverse, well, every other number, which is all numbers that have an absolute value of x means distance from 0, all x values that have a distance greater than or equal to 1 from 0, that's all that means. Okay. Once again, all the orange stuff you don't have to know to compute or evaluate cosecant inverse values. The most important thing from this slide is cosecant inverse and sine inverse have the same range. That's what matters. And you already know, if I want to find cosecant inverse, flip and find sine inverse. Okay. Boop. We'll not talk about any more domain today. It's all about the range. Secant inverse equals some angle. Okay. That means, well, definition. Secant of theta equals something, some ratio. Swap the inputs and the outputs. And now, if I want to find secant of an angle equals this value, I know by definition, now this is straight definition, that I'm going to find the reciprocal of this. Okay? So the reciprocal of this, you may have memorized this, but if you didn't, let's actually compute it out. So 3 over -2 root 3 is the reciprocal. I'm going to rationalize, just to kind of jog your memory. Root 3 times root 3 is 3. 3 times -2 is -6. 1 over -6 is -1/2 root 3, which is just negative root 3 over 2. So you might already know that when you find the reciprocal of 2 root 3 over 3, it's root 3 over 2. Negative makes it negative. So here's how we're thinking about secant inverse. If I want to find this angle, I need to find cosine theta of that. Well, where does the inverse of cosine live? The inverse of cosine lives 0 to pi, okay, in the first or second quadrant. So all around the world to say cosine inverse has a range between 0 and pi, well, so does secant inverse. Secant inverse also has a range between 0 and pi. So, we move all this out of the way, just like we're in class. I'm actually erasing stuff. Okay, so here's the process. To evaluate a secant inverse problem, here's what you do. Secant inverse of -2 root 3 over 3. means find cosine inverse of the reciprocal. Bow. So if you want to find secant inverse of a number, you find cosine inverse of the reciprocal. And then, since now it's a cosine inverse problem, just like we did in the last video. So cosine of theta equals negative root 3 over 2. Theta needs to live not in the fourth quadrant. Be careful. My x-coordinate is negative, which means I'm on the unit circle. My x-coordinate is negative root 3 over 2 in the second quadrant. What angle is that? That angle is 5 pi over 6, so theta must be 5 pi over 6. So just to recap, every secant inverse problem is find cosine inverse of the reciprocal of the input to find the angle. And that angle must live between 0 and pi, and we already know that. All right, so that's cosecant inverse in terms of sine inverse, secant inverse in terms of cosine inverse, and now our last inverse trig function, cotangent of inverse. Okay, so I'm going to explain this differently now. Once again, I don't really teach cotangent in terms of tangent. So here's cotangent. So let me give you some background. When we graphed the cotangent function, quick recap, we graphed it between 0 and pi, one full period, and the graph looked like this. Okay? So, now, you know that the function continued forever. There were infinitely many branches of decreasing functions that looked little branches that were going down. Okay, so I know what I just made a rough sketch of is not the entire cotangent function. That's just one branch of the cotangent function. So when you build the inverse of cotangent, it's not really the inverse of cotangent. It is simply the inverse of this little piece. So let me just say, this is the original cotangent function light, meaning just a piece of it, not all of it. To build the inverse, here's the graph of the inverse. Okay, so I took the 0 to pi, those are my x values, and now those are my y values. Remember, that's what an inverse function is, just swapping the x's and the y's. My range was negative infinity to positive infinity. Those were my y values. Well, now those are my x values. So here's what happens to the actual graph. Still decreasing. Instead of vertical asymptotes, the inverse will have horizontal asymptotes, and the graph looks like this. Very similar to what we saw for the tangent inverse function. So this is an actual graph of the cotangent inverse function, and the only reason I'm making a rough sketch of that is so that you can see it's going left and right forever, which means the domain is all real numbers. So cotangent inverse has a domain of all real numbers, and the range is between 0 and pi, but not inclusive. That's crucial. The cotangent function, the cotangent inverse function, has a range from 0 to pi, not including 0, not including pi, on the unit circle. So this is my way of saying when you're finding a cotangent inverse function, the angle, the output, is between 0 and pi, but not including 0 and pi. Okay? Do you have to know the original graph of cotangent? Absolutely. Do you have to know the graph of cotangent inverse? Not at all. Do you have to know the range of cotangent inverse? Big time. You got to know all the ranges of all the inverse trig functions. Okay, so now let's work a problem. So now that we know that the range lives here, I can evaluate. That's what I need to know. So, same question. Cotangent inverse of a ratio equals an angle means cotangent of some angle gives me negative root 3. So what angle between 0 and pi will give me out this ratio? Well, cotangent was defined to be x over y. Just like tangent was y over x. So now we're working backwards, and my hope is that when I write this, you're like, oh yeah, I know that. So the output is negative root 3 over 1, which came from negative root 3 over 2 over 1/2. X value, so on the unit circle, my x value is negative root 3 over 2, and my y value is 1/2. I have to be in the second quadrant. So just know, for cotangent, if you have a negative input, you have to be in the second quadrant. So where did that negative root 3 come from? It came from negative root 3 over 2, x value, and 1/2 as my y value. Well, what angle takes me there? What angle takes me to this point? And the answer is 5 pi over 6. And I loved some of those presentations in class because you knew, oh, I'm in the second quadrant, negative root 3, and then there are only 3 points between pi and pi over 2. So only one of those points, when you put the x-coordinate over the y-coordinate, is going to give you negative root 3. So I just want to remind you, with cotangent and tangent, you have to do this kind of working backwards. I need to find an x-coordinate and a y-coordinate that gives me negative root 3. Well, those are my coordinates. Therefore, my angle is 5 pi over 6. All right. So we did one good example of cosecant inverse. Cosecant inverse, you use sine inverse. Secant inverse, you use cosine inverse. And then cotangent, you actually think about cotangent. So cotangent is a cotangent problem, but you have to know the angle lives between 0 and pi. The range of all of these matter. So this is a quick recap. Everything I'm about to write you already have in your notes, but I need you to know from 0 to pi inclusive, you have cosine inverse and secant inverse. So the range of cosine inverse and secant inverse is 0 to pi. The answer to any of those problems must be an angle between 0 and pi. Now, 0 and pi, not including 0 and pi, that's where cotangent inverse lives. Okay, so you can think of all three of these functions living between 0 and pi, but I do want to make the distinction that 0 is not in the range of cotangent inverse, neither is pi, but all the other angles are. Okay, and then all the other angles live between negative pi over 2 inclusive and all angles to pi over 2. And this is my sine inverse function and my cosecant inverse function. Okay, and similarly, tangent inverse lives here. Okay, and I'm fudging something, so just to be clear, for cosecant, let me do it in orange. Secant and cosecant have those, undefined values. So just kind of be careful with that. Okay, meaning you will never get pi over 2 out of secant because cosine of pi over 2 is 0, so secant of pi over 2 is, undefined. So something weird happens here and here, something weird happens here, undefined, cotangent, undefined, cotangent, undefined, secant, undefined at pi over 2, and cosecant is undefined at 0. Once again, that has nothing to do with evaluating necessarily, but we can deal with that later. Okay, so hopefully You'll start those practice problems. You can find the inverse of any secant function, any secant value. So secant inverse, cosecant inverse, cotangent inverse of any value. Have at it, practice, and I will see you guys in class. 20 minutes, let's go.